Hi guys, we're talking about geometric probability today. This is going to seem a lot easier compared to 13.2. So geometric probability is using your length and area to find the probability of an event. And I always think of everything, when you think of probability, as a fraction, a part to total. Part to total. So on this one, it's saying if a line segment 1 contains another segment 2 and a point on the segment 1 is chosen at random, then the probability that the point is on that segment 2 is, so it's almost again, it's a little part to the whole. So this one is choosing E, so if point E on AD, so we'll just choose it anywhere, then the probability of E is on BC, so we have B to C here, which is part of this total. And you can actually see it better there. So that's how you would do that. So that makes more sense. All right, so let's see what we've got here. So also, if we wanted those into a percent, so sometimes probability is a percent. And if we want something as a percent, we simply multiply by 100. The word per means to multiply. The word cent means 100. So it's telling you what to do. It's one of my favorite math things. So let's say that point Z is chosen at random on A to D. So here. Find the probability that Z is on AB. Well, how far is AB? AB is 2 units. And my total A to D, we have to add those up. So 7, 8, 9, 10, 11. We're going to multiply this by 100. And we can get 18%. We're just going to. Some of you still like to divide this, so 2 divided by 11 times 100, or move that decimal point over twice, and that's fine too. It's the same thing. Yay, do you feel much better so far? So, orbits. Halley's Comet orbits the Earth every 76 years. What is the probability that Halley's Comet will complete an orbit within the next 10 years? So, here's the 10 years out of my total. How many years is this? Does it say? Oh, it says 76 years. So it's 10 out of the 76 times 100, and the probability is 13%. Next. So that was length. Now we're going to talk about area probability, and this one was a little bit weird as well. So if a region A, so you're taking this big thing here, A, and you have B, the circle inside of A, and the point E in a region A is chosen at random, then the probability that point E is the B to the A. Same sort of thing, but it's kind of hard to think about it. So on here, it says the targets of the dartboard are formed by 3 concentric circles inside one of each other. So here's, they don't count this outside. So that's 1, 2, and 3. Okay. If the diameter of the center, so this whole thing is 4. So half of it's 2, right? And there's 3 inches apart. So we have 2, and then this is 3, and then this is 3. Gosh, it's hard to see that. Okay. What is the probability that a player will throw a dart into the center? So, what is the area of my center? First of all, we need to know that A is equal to pi r squared. So what is the area of my center? So we're going to say 2 is my radius, squared times pi over the area of that dartboard. So this black area doesn't count. So we would say, what is that? 3, 4, 5, 6, 7, 8 squared pi. Then we're going to cancel this out, and we're left with 4 over 64, which simplifies to 1/16 times 100, and you'll get 6%. Okay? That one was a little harder, just because unless you know the dartboard, this is kind of really confusing about this black edge. It doesn't count. All right. This, use the spinner to find P, pointer landing on section 3. So the probability of landing on section 3, which is 122 degrees, over, and how much is a circle? 360, or you could have added them all up, multiply it by 100, and you should get about 34%. Okay? Use the spinner to find landing on section 1. So section 1 is 26 out of the 360. Change that, and you get 7%. So pay attention. Do they want it as a ratio, part to total, or do they want you to put it into a percent? All right, so tomorrow we're going to do two-ways tables, so enjoy that sweet little lesson. And again, let me know if you have any questions.